With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, the question is a 1 molar solution of cadmium 2 positive is added to excess of iron and the system is allowed to reach the equilibrium. What is the concentration of cadmium 2 positive? The reaction is cadmium 2 positive plus iron solid forms cadmium solid plus iron 2 positive and E naught for the reaction is 0.037. So in this question we are given that 1 molar solution of cadmium 2 positive that is added to excess of iron and this system is allowed to reach at equilibrium. It means this system is at equilibrium. This reaction we have to calculate the concentration of cadmium 2 positive at equilibrium. So first if we write the reaction, that is cadmium 2 positive aqueous plus iron solid, it is forming cadmium solid plus Fe2 positive aqueous. Now let's say at time t is equals to 0, this concentration is 1 molar given, this is in excess. So at the time t is equals to 0 they will be nil, and at equilibrium let's say x amount will be dissociated. So if it is present in excess, then x amount of this will form and x of this will form, but the cadmium which is present in solid, so its concentration will not affect the equilibrium, so we will not write its concentration because it is not included in the equilibrium constant also. So if we write the equilibrium constant for this, that is the concentration of the products raised to power their stoichiometric coefficient divided by concentration of reactants raised to power their stoichiometric coefficients, and these concentrations are at equilibrium. If at any stage of this reaction this ratio is calculated, that is known as reaction quotient, and reaction quotient is equal to the equilibrium constant at equilibrium. So now it is given that to reach equilibrium we have to find the concentration of cadmium 2 positive at equilibrium. So we will calculate the equilibrium constant, that will be the concentration of product, that is x, to the concentration of cadmium 2 positive, that is 1 minus x. So this will be, now at equilibrium the E cell, that is the potential of the cell, that is equal to 0. So if we use the Nernst equation, which is the E cell equals to E naught cell minus 0.0591 divided by n log q, or at equilibrium that q will be k. Now E cell will be 0, so E naught cell will be, E cell is 0 at equilibrium, and k value we have x upon 1 minus x. Now if we write E naught cell, that will be equals to, if this is 0, so this will come here, this negative will be cancelled by negative, so it will be 0.0591 divided by n log k. Now n is the number of electrons that are involved. So when cadmium it is present in 2 oxidation state, it has gone to 0, it means it is reduced or reduction has taken place, and that involves 2 electrons. Also iron that is present in 0 oxidation state, it is oxidized to iron 2 plus, it means it has oxidized. So also 2 electrons are involved, it means the number of electrons that are involved in this redox reaction in both oxidation and reduction, that is 2. So n value will be 2. It means n value for this reaction is 2, and E naught of the cell that is given as 0.037. So if we put the values, that will be 0.037 equals to 0.0591 divided by 2 log k. It means log k is equal to 0.037 into 2 divided by 0.0591, and that this value comes out to be 1.25. Now we have log k, so we have to find out the antilog of 1.25. So k will be antilog 1.25, and that is equal to 17.78. It means this is the equilibrium constant, 17.78. Now we have equilibrium constant k, and that is we have calculated that will be equals to this, which is x upon 1 minus x. So if we calculate the value of x from k, that will be 17.78 divided by x upon 1 minus x. So this will give us x as 17.78 minus 17.78x, which is equal to 18.78x equals to 17.78, and x will be 17.78 divided by 18.78, and this value comes out to be 0.947. So x, what does x? X is a concentration of iron 2 positive at equilibrium. So we can write the concentration of Fe2 positive at equilibrium, that is x, which is equal to 0.947 molar. And for cadmium 2 positive, the concentration at equilibrium is 1 minus x. So this will be 1 minus 0.947, that is 0.053 molar. So this is the concentration of cadmium 2 positive at equilibrium, 0.053. So the correct answer to this question is C option, 0.053 molar. I hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.